Solutions to assignment questions. To start with, let me remind you that you should always draw two light rays from a single point of the object in order to locate the image. In the picture, you can see the head of the polar bear is here, but then its body is on the right. Remember that his body is inside water, and so what you see here is actually the image of its body. So the object is here, and then you draw two light rays, produce it backward in order to find the image, and the image should be on the right of the object. We use the same scale to complete the diagram, but before that we draw an arrow along this direction, just next to the edge of the cup, and then this light ray does not pass to the observer eye. This shows you that the observer cannot see the cone before water is added. When water is added, then light ray may go this way. And don't forget that you should draw two light rays from one point of the cone, and afterwards draw the virtual rays in order to locate the image. We use the same scale again, and this time you may imagine there is a very small cone here on the bottom of the pool. And the light ray go this way, so that the boy may think that the light rays come from this point, which is an image. And so the whole bottom of the pool will appear here, which is the image of the bottom of the pool. Now the boy observed a fish in an aquarium, in a fish tank, and then they are about on the same level. So we draw light rays in this way from the mouth of the fish. And these light rays bend away from normal when they go from water into air. Then the observer would believe that the light ray come from here, and this is then the image of the fish, which appears to be closer. This is pretty similar, but this time it is the fish which sees the boy. So we draw light rays from the boy, and this is reflected towards normal when it enters water. We draw the virtual rays to find the image of the boy, and so the boy appears to be further away. For this question, you may use 2.998 times 10 to the power 8 meter per second to be the speed of light in vacuum, or you may use 3 times 10 to the power 8 to be the speed of light. And in these cases, if you write your answer in 3 decimal places, they will be the same, like this. For this question, you are asked to prove that the angle of deflection is this value. What you have to do is find the angle of deflection due to the first refraction here. This is the angle of deflection, D1. It is given by 16.47 degrees. Next, then you have to find the angle of deflection, due to the second refraction, D2. This is the angle, D2, and it is given by 32.31 degrees. So the total angle of deflection is given by D1 plus D2, 49.18 degrees. Thus, as a similar question, there is a refraction here and another refraction. You have to find the deflection due to the first refraction, D1. Similarly, find the deflection due to the second refraction, D2. And so, the angle of deflection when the light ray travels through the prism would be D1 plus D2.